Hello everyone, and welcome back to another GIS statistics lecture video. In this video, I want to talk about our second, or I guess third in this case, method of approaching interpolation. And this one is going to be called inverse distance weighted. Right, inverse distance weighted. And what I kind of want to do before we even do anything else is just walk through the name and break the name apart, because this really tells you everything you need to know. Right? So the first thing is this word weighted. Right? So we know that what's going to end up happening is we're going to end up weighting, which basically just means multiplying by some number. What's that number going to be? Well, that number is going to be the distance. Right? It's weighted by the distance, but not just any distance, the inverse, right? This inverse right here, right? Inverse distance weighted. So that means it's going to be weighted by the inverse of the distance. And the inverse in this case just means 1 over. So what I want to do is I want to walk through sort of conceptually what this means, right? Let's say we have, again, our normal 3 points here. Right, we have point A, point B, and point C. And we're trying to figure out, again, the value of this unknown point here. What inverse distance weighting is going to say is that, well, all 3 of these points are going to contribute to our value, right? We're not doing nearest neighbor where we just take the closest, right? We're not doing linear interpolation where we're basing it off of 2 points and we're drawing a straight line and we're figuring out how far apart. Instead, we're saying all 3 of these points, like we could have 4, we could have 5, we could have a lot more. But in this case, right, all 3 of these points are going to contribute to the value of our x here. But they're going to contribute based on the inverse of how far away they are. So what that means is that the farther away a point is, the less it will contribute. To the estimation. Right, and this makes logical sense, right? It's Tobler's first law of geography, right? Things that are closer together are more related than things that are distant. So you would expect that, if I were to undo our example here, because this is kind of in the middle, right? If I were to move this point, say, over here instead, so that it's, really close by. If I were to move this point over to here, right, we would expect logically in a geographic setting, right, that its value would be closer to A than it would to C or B. And that's what this inverse distance weighting does. It makes it so that the point's value is going to be closer to the values of the points nearby, and is going to be less influenced by points that are farther away. So hopefully conceptually this makes sense. We're going to walk through the equation in just a second. But again, just to reiterate, the idea here is that we're weighting the value by the inverse of the distance of the point we're interested in and all of the other points that we're considering. So what does that look like in terms of an equation? Well, the equation looks something like this. We're going to take the new value, so the z of some unknown, we're going to call that x, right? The z of some unknown, so the value of some unknown point is going to be equal to the sum of the values, right, of all of the points that we're considering. So this is what z sub I means. So all of the values we're considering times this thing we're going to call a weight, which is this w here, divided by the sum of all of the weights. Now, what is this weight? right? That's kind of the critical part. What is this wi? Well, wi is simply going to be 1 over the distance between the point x and point I, raised to some power we're going to call alpha. That's a terrible alpha. Raised to some power alpha. So let's break that down again. This weight that's going into this inverse distance weighted equation is basically, this is the inverse distance, right? It's 1 over the distance between the point we're trying to estimate and the point that we're looking at. This is the point we don't know. This is the point we do. Raised to some alpha. So I want to take a second here. I want to talk about alpha. What does alpha do? Alpha controls how important distance is. Let me repeat that. This alpha controls how important we want the distance to be. Typically, you'll see a 1 or a 2. But let's just consider for a second what happens when we make the distance 0. Right? If we make this value, this alpha value here 0, what we're saying is that this whole thing, regardless of what the distance is, when you raise something to the 0 power, it becomes 1. That's a definition. Hopefully you knew that already, but that's just a definition of exponents, that anything raised to the 0 power is 1. So if we make the alpha 0, what we're saying is that regardless of distance, we want this denominator to be 1, which means 1 divided by 1 is 1. This becomes 1, and this becomes 1. So if alpha, God, I cannot draw alpha today. If alpha equals 0, then IDW, inverse distance weighted, is simply the mean. Simply the mean value of the z's that we're considering. Again, if we make alpha 0, then we make this whole thing down here go to 1, which makes this wi go to 1, which makes this equal to the number of points that we're considering, and this equal to the sum of the z values. So if you divide the sum of the z values by the number of points, you get the mean. We've just collapsed this thing down to be the mean. So if alpha is 0, we don't care about distance at all. Hopefully that makes sense. 1 is the standard, where we're basically just taking distance. If we use 2, then we are increasing the importance of the distance. All right, 0 means we don't care about it at all, and 2 and greater means we really are penalizing points that are far away. I hope this makes sense. Again, I just want to walk through this, right? Ideally, what we're doing is we're taking the z value for the point we're interested in, or one of the points we're looking at, multiplying it by the weight, which is again just the inverse of the distance between the point we're estimating and the point we're looking at, raised to some alpha, which sort of controls how important we want that distance to be, divided by the sum of those weights. And that's going to be the z value that we're considering. Hopefully that makes sense. If any of this was confusing, I really encourage you to go back, rewatch the parts you're confused about. And as always, please reach out. Thank you.